Hi, for today's YouTube video, we are going to discuss about a small program that was written using a Java. We used string buffer concepts and array concepts. You can see it is a small test class. We declared a string st equal to hello. Okay, it is a string. So the expectation is we want to reverse the string. So how many ways we can actually reverse the string, you can see. I explained a couple of reasons, not all the reasons. So you can see the first thing is first way is we have string buffer. So string buffer class is having multiple methods inside. So reverse method is one of the methods. It is very simple and straightforward. You can simply apply dot reverse method in string buffer and it will reverse the string internally and we will get the reverse string. It is a simple approach. Another approach is you declare a character array and you convert the string into a character array using a 2char array method. So that converts the string into character array. And now you just take a for loop. You're going to take a for loop, and inside the for loop what we are going to do, we declared a stack object. We created a stack object, and since we are iterating using a for loop, right, and inside the for loop we are pushing each character to the stack object. Okay, by iterating character array we are pushing each character to stack object. So here if you face any typecast issues, right, you can actually use the string dot value of method to convert that into a string. You can convert the character into the string. Okay, you can see you can also use character dot value of method. So if you face any typecast issues, you can actually use that. So for now I just specified directly. And another method is you see okay, after pushing the character to the stack we need to pop all the characters, and I'm going to append each character to a string buffer. Another string buffer I declared here, stbr. You can see I'm going to append each character. Since we are popping the stack, right, the characters will be popped in reverse order. It is like a first in first in last out scenario, right? So the very recent values will be popped, and we will get the reverse order here. Another way is you declare a for loop, take a for loop, and initial character is character dot length of -1. I'm going to take a last character and assign that index to integer I, and I greater than or equal to 0, I minus. So I'm going to concatenate the character array. Again here I declared a string reverse empty variable. I'm going to concatenate each and every character to my string using a plus operator. So here also if you face any typecasting issues, you can use again typecasting methods. Okay, that is a simple program. So another thing is, in the real time nowadays in IT, I want to explain what are the technologies that we are going to use here for this YouTube video. You can see Java is predominantly the best programming language that we are using for developing applications. So Java is a very good programming language. And Spring framework, still many companies and banking sector, they are still preferring to use the Spring framework. We have a multiple frameworks. Micronaut is one of the framework. Recently it is coming to the picture, and there are other frameworks. They are actually reducing the compile time, dependency problems, and running time issues or performance issues. they are trying to reduce the latency. So many frameworks are coming to the picture, but yet Spring framework is a standard and stable, secure framework. It is a proven framework. Most of the clients and companies are still using the Spring framework. If at all, if you are going to use a Java programming language, okay. So the Spring framework generally use it for dependency management and for writing the API or application logic. So we have a technologies for backend layer. We have a JDBC for connecting to the data sources. Backend layer we have a JDBC and any ORM framework. Java database connectivity, JDBC is plain Java features provided with the Java. So for connecting to any data source, it is a very straightforward and native. If you are going to use JDBC, native JDBC, it will be faster. But the problem is you need to write everything from the boilerplate code. Okay, you need to handle all the connections and the connection opening. After using the connections of data source, you need to make sure you close the connection object properly. You have to create the connection pool for handling multiple requests. In production, if you are creating enterprise application, you need to handle the connection pool management, right? The Spring with any other ORM framework, by default there are inbuilt mechanisms for handling connection pooling and other transaction management. But if you are using JDBC, you need to take care of all those things, right? But if it is a simple applications, medium size application, you can use JDBC. Okay, it is very straightforward. Using a JDBC, you can actually write multiple SQLs. You can fire the multiple SQL to database directly. You can also call PL/SQL procedures in JDBC. If it is a ORM framework like Hibernate, MyBatis and other frameworks, so you need to map the data to the entity tables, and after that you have to manipulate the entity object. Okay, that is also recommended approach, but nowadays, but I would prefer to use JDBC because I can directly call the SQL or PL/SQL instead of using ORM frameworks. In my opinion, right, why do you want to map data to POJO and you want to serialize, deserialize? Why do you want to do that every time, right? And you have to manage all these query, SQL queries using a program, using ORM framework. You need to learn from third-party frameworks. You need to inject the dependencies into into your project. It is a little bit, it is kind of tedious work, complex. You are making a project complex. You can directly use Java, okay, Spring framework for creating API and JDBC for writing direct native SQLs or calling PL/SQL procedures. Okay, up to then you can use it. You don't need to use the ORM framework. But some people, they prefer to ORM framework. It is up to you. But my suggestion is go with JDBC, Java Spring Boot, Java Spring Framework and JDBC. A Spring Framework also, you should use the Spring Framework only if you really require this framework. Otherwise, you go with plain Java and JDBC. Okay, try to complete any system application or application using only pure Java and JDBC. Try to avoid Spring Framework and ORM frameworks until and unless it is very big project and complex project. You really need to handle the dependency, meaning lot of dependencies. Then go for Spring Framework and ORM. If your application is very simple and straightforward, it is simple system application. You want to automate couple of things, or you want to create some bad jobs, or you want to create some workflow, you can directly use a core Java and JDBC. Don't go for frameworks. Okay, don't complicate the project. Don't make it a complicated. Why do you want to use different third parties? So if you are very, your language is Java, favorite language, and you want to use this particular language and its native features, and if you are adding third party features or third party frameworks into your Java, it may pollute your actual intention of using Java. Sometimes you may not be able to write the efficient thing, so you are making it complex. So why do you want to make it complex? Why do you want to take the overhead for creating a simple project using native Java programming? So my approach is just use pure Java, core Java, very powerful general purpose and object oriented programming language. Try to avoid a Spring framework or ORM frameworks until and unless you really need to create a very complex project and you want to handle dependencies. Then go for a Spring framework and ORM framework. My suggestion is for simple and medium sized project, you don't need to go for Spring framework. Even if it is medium to large kind of complex, you don't need to go there. If you well manage the structure and all, don't need to use it. Okay. Try to use the core Java and JDBC. Try to complete it. You can actually write multiple modules and you can create a monolithic application just using core Java and microservices. And see, monolithic versus I'll talk about that later. Other thing is UI part. So there is a UI. Nowadays we are seeing a lot of websites, right? And if you open any website, open a Flipkart, eBay, okay, or you can open any other website, you can see IMDb, movies now. So you try to open multiple websites. They are having a beautiful sites, beautiful user interfaces. So many user interfaces are coming with a rich set of animated elements, graphic content. They are making it very beautiful. They are designing very beautiful user interfaces, and they are using many technologies like HTML, CSS, Bootstrap, JavaScript, jQuery, Ajax, AngularJS, React.js. So many Java, so many HTML related technologies and CSS. Many animations are they are every day new animations are being introduced using CSS and Bootstrap. Okay, and you can also use jQuery, Ajax or pure JavaScript for calling APIs from the front end. AngularJS and React.js frameworks, you can actually they will modularize the front end code also. If you want to modularize, you want to create MVC kind of project for UI, you can go ahead with the AngularJS. If you want to use you want to play with the dynamic DOM elements, and you can use actually React.js, because you can create the things using component based, and then you can actually play with your document object model and dynamically. So you can go with React.js. That is there. The thing is, the problem is, nowadays the websites are not very user friendly. They are making them very complex. They are not user intuitive. They are making them very clutter, very complex. So users are losing interest when they are trying to navigate the website. So they are making it very complex. Even general normal user, if they open any website, they are unable to find out. You take Indian government website, IRCTC, or any government service. So they are creating lot of menus, lot of elements, so lot of different rich set of context. There is no structure, there is no proper they are not very intuitive, they are not user friendly, I can tell you that. So that is why it's giving a kind of headache to the users whenever they are going to. So you want to reduce my suggestion is you have to reduce the complexity at UI side, because the people, they love to use the UI when it is very simple and straightforward, very intuitive to the user. The user, they don't need to feel strain while using the web application, any website. They don't need to find it very difficult to use the UI. You may include multiple features. You don't need to include multiple features in a single website. Getting my point, right? And you try to simplify the user interface. Okay, try to simplify the user. Keep very minimal functionalities UI, or you make it simple, because nowadays if you look at the chat GPT, you want to just search anything, there is a single prompt and it's going to give everything. It's going to give you the search tags, search engine, search result, or if you upload any image, it is going to analyze that image and it's going to give some analytical data, some analytics insights. You can get that, right? So if you upload a video, it will also explain what is that video, and you see how AI is going to be useful here. So ChatGPT it is not very complex UI, it is very simple. Initially when they released it, they just released it as a some text box for entering the prompt and submit button, that's it. The remaining thing they are doing it, and you see the way how it is going to be. So what I'm thinking, in future we are going to see most of the websites like that. We want to use some AI concepts and agents concept, MCP servers. So they're going to simplify it, right? You don't need to actually remember the domain, and you have to navigate particular menus, particular tabs, and you have to open certain things. Okay, and if something going wrong, and you need to repeat that from the starting, sometimes it gives a overhead to the user brain, and their user lose the interest in using a website. I personally feel like that whenever the website is very complex and very complex to use, and I feel a kind of clutter when I am using the website, I literally exclude using that website. I don't like to use that. I will try to choose some kind of simple website where the user interface is very simple. Even the kids also will be able to understand what is the particular website is providing the services, you see. So that way you will get a lot of traffic when you design your the company or your website in such a way. If it is very intuitive and very straightforward, you will get a lot of traffic. Okay, you don't need to make it very complex. That is my opinion. So different people will have different opinions. So my opinion is, whenever you are designing that, you go in that approach, keep that in mind, and design the application as simple as possible, very straightforward, very intuitive to the user, very user friendly. These things are very important, right? You don't need to create a lot of tabs, menus. You look at the government websites, local state government or central government, they're making things very complex. So that's one of the reasons. So the people are not even using that. You have to make the things very popular, because if you look at, we'll have different people in the society. Most of them are illiterate, most of them are not well educated people. They are not the computer aware people. They have a basic knowledge of the computer. So if you are making website very complex and very overhead, so the people may not prefer to use it. They will go for other options for the government services. So that is my advice, my opinion. So other thing is, whenever you are going to build a system, you can build a system in two ways. One is the monolithic approach. Monolithic approach is you're going to build a project. You're going to use a single project to build all modules. You may have different functionalities, so you want to build different functionalities using modules, and you will create a single project. So there will be a single project. It is very simple and single project. That's what again I am telling you. Don't need to create a very complex project. Okay, make them as simple as possible. The project also should be very simple, should be understandable. Okay, you try to create the project using code, simple pure Java, core Java and JDBC. Don't use any third-party dependencies. Don't use any frameworks, right? Why do you want to use? Until and unless you really some requirement. Let's say you want to read some PDF data, right? Then use some dependency, PDF reader related dependencies, or ORM scanner related. You want to use them, so you can use it. Until and unless you really need a dependency, then use a dependency. Jars. Otherwise, don't include it. Otherwise, don't include the frameworks also. Do not include the ORM. Okay, go with the pure Java and SQL and simple project. Do not create multiple modules also. My opinion is, why do you want to create multiple modules? Some people, when they create a project, right, they will create multiple modules, multiple packages. They will complicate that thing. Why do you want to complicate them? If you are having, so if you can complete certain project in 10 classes, 10 to 13 classes, complete it in 10 to 13. Why do you want to create, for every class some people create 10 packages. Why do you want to create a packages? So it will create a complexity. You can give a meaningful name to your classes, and then create that complete that a project in 2 or 3 modules. You don't need to create multiple modules. Okay, and do not make it very complex. So monolithic approach is a very straightforward recommended approach. If you are going to create any project using only core Java, JDBC and monolithic style, using 2 or 3 packages only, you can create multiple classes under that. Do not make it very complex. Okay, so microservices, you can create API. You can also create API using monolithic, using core Java itself. You can directly use, there is a way you can actually create a API using pure core Java. Okay, and then use it. If you want to go for microservices, sometimes people, they want to create a domain driven architecture. For each domain they want to define multiple domains, multiple functionalities. So they'll create a multiple API and they'll use that, and they'll use the Spring framework, ORM framework. Okay, they'll create a API as a backend project, and front end there is another UI project. They'll integrate both using these AngularJS routers or React.js routers. It is very complex. That is what, if you really need want to handle that much complex project, you handle it. Okay, my suggestion is, I will try to avoid those complex thing. I want to do the things only pure Java and JDBC. Okay, and at the front end side, I don't want to make it very complex. It is very I want to make the UI very simple, in a simple way, user intuitive thing is a very important factor for me. Even kids should be able to understand the website. Even the uneducated person, even the less educated person should be able to understand the website. You should be able to Utilize the government services or any services, corporate services, whatever it is, whatever the purpose you are going to create a web application, right? You need to consider that. My question is, why do you want to complicate things? Of course, many people, they'll create many ORM frameworks. Many people create many frameworks. Everybody, every day, they'll create something new. They will come up with something. Why do you want to purchase things from other ocean kind of market? It is a third-party market. When you have a core Java, you try to utilize the core Java as much the core functionalities that you can use. So I don't want you to mix other things. When you are mixing third-party dependencies, libraries into core Java, it will lose its the core behavior, the Java. You are going to create some overhead on the Java programming. Unnecessary complexities, complex things you are actually mixing with the core Java. Okay? Should not do that. So the Java is object-oriented program. It is very plain. So there are a lot of features. So many APIs, many features are introduced as part of the Java program. You can do everything using Java. You don't need to utilize the third-party things. So do not use ORM frameworks or Spring framework or some other Struts framework or any other framework until and unless you really need them. Otherwise, try to do the things in pure core Java, because you want to keep the sun as clean as possible. You want to keep the sun as clear as possible, as simple as possible. So the application can be attractive to all kinds of people. It will not be restricted to certain people. That's what I am trying to tell you. Getting my point, right? So you can mix, if you are going to mix multiple third-party libraries to Sun Micro systems, Java. So the Sun Java, you should not mix the dependencies. Why do you want to mix? Why do you want to make it very complicated? Let's keep it very clear and simple, precise. Okay, pure core Java. If it is Sun's Java, keep it Sun's Java. Why do you want to mix it? Getting my point, right? So do not mix it and do not create the projects like that. And do not encourage like that. Until and unless you require some dependency, then only pull the dependency. You take a real-time examples, right? Any examples. If you can do anything, you will do it. If you are not able to do it, then only you will take the help from others, right? If you are including all other people's, multiple people's, into your work, it will create a nonsense. It will bring you the overhead. It will kill your privacy, your freedom. Okay, you will lose the core behavior of your thing. That is the real-time example. So already core Java, Sun Java is there. Why do you want to mix the things? Do not mix the things. Do not mix the dependencies. Do not mix the codes that were developed by multiple nonsense people. You don't know who developed the third-party dependencies. There are many kinds of people are there. Okay, even some people, they create the dependencies for dark web, from anti-social elements. So they create many dependencies, many softwares. So when you are combining them with your Java project, including Sun Java, you are corrupting the Sun, right? That they're the issue. So that is why try to avoid the third-party dependencies. Do not use ORM frameworks. Do not use Spring or Struts framework, any other frameworks. Why do you want to? Try to complete or finish the things using core Java related features. Any application, any automation, any system application, any simple application. Even if you want to build an API, complete it in API using a simple Java itself with minimal dependencies, minimal modules. Try to do it in monolithic way. Okay. So that is my opinion, my suggestion on this Sun Java programming. Okay. Do that in that way. So that way you will keep the Java as fresh as possible, as simple as possible, as clear as possible, as perfect as possible. When you combine the things, when you mix the things, then you will see the problem. There will be the problem. There is definitely a problem from multiple dependencies. So when you use multiple dependencies, you don't know from where the problem is coming. If you are mixing and using frameworks and other things, you don't know. So tomorrow if something happens, some problem arises, some exception coming, some error is coming, you don't know where that error is coming. You don't know how to fix that issue, because you have used and combined, mixed multiple hybrid mutations into Sun Java. How do you fix them? It is also overhead, complex process to fix those things. You look at the zombie movies, right? So how it happens when you combine the things. So that is why try to keep the Sun Java as pure as possible, as simple as possible, as clear as possible, as transparent as possible. Okay, then you can manage and maintain the Sun with a clear picture. And also the audience, the multiple audience will try to use it. If it is simple, as I told you, the UI is very simple, very intuitive, then kids also will access that. Otherwise they don't use that. Only the computer scientists, or only those who studied engineering for 4 years or 14 years, they will only use it if you make it complex. Or if you want to get all the audience, you want to get a website that can be used by the kids, that can be used by the women, that can be used by the illiterate people, less educated people, you have to make the application as simple as possible. Then everybody will access it. If you are making it very complex, only certain group, only certain people will use that, and it will be dedicated to the only the particular people. Okay, that is the problem. So I'm just explaining in different context, different perspective. Okay, always everybody tell us to use frameworks, ORM frameworks, microservices, these different UI, CSS, Bootstrap, Ajax, Angular, jQuery. They'll tell lot of things. We don't want to use all that. We don't want to combine those things to complete pure Java program. Keep it as simple as possible, as pure as possible, as intuitive as you can build any application. Keep it very simple, okay? And other thing is the containerization. Okay, containerization somewhat better. But it is a kind of better technology. The thing is, right, nowadays we are having multiple platforms, multiple servers are there. Okay, and also cloud is also emerging nowadays. So you build some applications using Java, and you have to containerize them. Okay, and you can deploy. The thing is, if you build any programming using pure Java, and you can make it as a jar or var file, it is very straightforward. You can simple any jar or var in any other system. It is simple application, monolithic application. That is the advantage. So in case if you build any complex application, so you can also containerize them. There you can utilize the container. You have to containerize the thing. You need to contain all these different dependencies, different runtime libraries, different third-party frameworks you have utilized. In case if you build the application by mixing all these nonsense third-party dependencies, frameworks, ORM frameworks with the Sun Java, then you have to containerize this, because sometimes so that particular you are not able to run particular application in a specific server. Then you can actually, if you are able to containerize that using all these libraries, runtime libraries, then you can simply move this container to another server. You can deploy it in new server. There you can see how the Sun is running. You can test it there in different server. Getting my point, right? So you can also move the server to the cloud as and when you need it. You can make it dynamic nature. So that is the thing. Sometimes when you are using these libraries and frameworks, and if there is a vendor locking, then there will be a problem for Sun Java. Getting my point, right? You cannot lock your Sun to particular vendor. When you do that, you will lose the freedom. You will lose the dominance. You will lose the authority. There is a problem. What you have to do? You have to containerize that. Containerize all these things. Keep it as a containerize. And if you don't like the vendor, you don't like the server where you are running the Sun application, you can simply move that application to different server, different on-premises server. You can create your own cluster. You can purchase a separate server, you can run it there. Or if you don't like this on-premises servers, you can deploy it in cloud also. You can deploy it in cloud, Google Cloud. Or if you don't like there, you can move it to Amazon. If you don't like it, you can move it to Azure. Or you can move it to Pivotal Cloud Foundry. There are many private clouds also there. Okay, you can build your own cloud and you can deploy it there. Nowadays, so cloud is emerging as a mandatory technology. Okay, cloud and AI actually they're playing vital role, right? So you see, this is a AI competitive world and cloud competitive world. So containerizing applications very simple. Very flexibility will be there. So you will get the flexibility of moving your Sun code from one system to another system, one server to another server, based on the application performing. Your application is not performing, your Sun is not performing on certain platform. You can move your Sun to different platform. You can deploy it there. You can deploy in this region. You can deploy in another region. Okay. You can deploy in north. You can deploy in south. You can deploy west or east. Anywhere you want to deploy, because there is a cloud. There are multiple regions. Multiple servers are there. You need to containerize things. You need to containerize all your application code, runtime libraries, frameworks. You might have used third-party frameworks, third-party libraries, different vendor-specific library. When you containerize them, so you will have your application with all runtime entities. So you can deploy this container anywhere you want it. You see how we move the containers on ships. Okay, different containers. Very simple, right? For transportation, it will be very easy if you are having your things inside a container. So that is the significance of the containerization. I felt the containerization is very good technology. In future, almost everybody try to use the same kind of containerized technologies. So they will containerize the thing, because if at all they are going to mix multiple things into your project, you need to containerize them, so that you don't need to be afraid of how you can run your Sun code on particular platform. Okay, so that is the thing you need to understand here. You need to remember. First thing is, keep the Sun code as clean, as simple as possible, as clear as possible, as pure native as possible. Keep it as native as possible. Keep it as native as possible. Core Java. Use the Core Java and pure JDBC. And simply build application. Keep it very simple, monolithic application. UI also very intuitive. As I told you, all kinds of audience should be able to access it. Even kids also should be able to access it. Even women, less educated people, illiterates, anybody should be able to use the application. Keep the UI as simple as possible. You don't need to beautify it using a rich set of third-party elements. Why do you want to beautify it? Beautification is not important here. How useful is your system to others? How it is serving to broad range of audience. So heterogeneous people, they should be able to access your Sun code. If they are not able to use it, only if you are limiting or dedicating to certain categories of people, what is the use of your Sun code? Nonsense. It should be used by all sets of audience, all sets of clients, all sets of all categories of people. Otherwise there is no use. You take a leader. If leader is useful for all the people in the country, then he is a worthy leader. Otherwise, you tell me, what do we call him? It's a nonsense, right? If the leader is only useful for certain categories of people, what the people will do? People do not elect him, or do not choose him. They don't choose him. What is the use of that guy, the leader, a nonsense leader? That Bahubali will be killed one day because he is no longer required for all categories of people. Getting my point? So keep the sun as simple as possible. Do not mix multiple third party unnecessary frameworks, complex frameworks. Okay, all sets of categories of people should be able to understand. It should be very intuitive, the web application. So that is why you don't need to beautify your sun. Beautification is not required. Keep him as simple as possible, as native as possible. Just show him whatever he is, whoever he is, okay, whatever it is, whoever it is. Show him. Show the same thing, the natural beauty. Okay, keep it as simple as possible. It should be as natural as possible, and then it will be so powerful. If you keep it very simple and as natural as possible, it will be so much powerful. You don't know how powerful that is. It can break and damage anything that is coming as a competitor. That is my opinion. Okay. And if you are mixing lot of things, including multiple libraries, and you are trying to beautify it, fake beauty, if you are applying fake beauty, okay, irrespective of the performance and capacity, capabilities, what is the use of that? It is not going to be useful for all categories of people, including kids. Okay, that is the thing. And you see, cluster or cloud, I explained you can have your own cluster on-premises servers, or you can actually create a cloud. There are multiple cloud, public cloud, private cloud, hybrid clouds. Depending on the need, you can do that. Okay, cluster, so you can have on-premises, but if you have a money budget, you can purchase your own servers. You can establish your physical hardware infrastructure, and then you can build but you need to maintain them every day. You have to take care of those servers. You need to cool down those servers, take care of the purging scenario. Whenever the data is going to be stored, huge data is going to be stored, you have to take care of. You need to maintain the servers, right? So it is up to you. If the security is your concern, and you want to have a control, you want to have a dominance, you want to, if you feel that you want to have your own infrastructure, then go for on-premises servers. You can build your own servers. You can also build your private cloud using different clusters. Okay. Or you want to focus on your business, you don't want to bother about the server infrastructure, server maintenance, then go for cloud. My suggestion is then you go for cloud, because you want to focus on core business operations rather than the IT infrastructure, servers, maintenance, hardware, security. You don't want to bother about all this stuff. Simply deploy your simple applications built by pure core Java and these things into cloud. You can deploy it in different regions: southeast region, northwest, northeast, different region. US, you can deploy in US, you can deploy in Britain, you can deploy in Germany, you can deploy in China, Russia. So any the cloud is everywhere. Different regions are there. You can deploy it depending on the requirement, depending on the need. Okay. And other technologies are serverless cloud functions. Cloud functions concept is a new concept. As I told you, right? Most of the people, they worry about the infrastructure management. they worry about the servers, because if you build any application, building application is one hard part. Another hard part is deploying it and managing it is another hard part. So serverless concept avoids the deployment and management part, because the cloud will take care of all this. Other guys, other people, whoever is managing this cloud sector, they actually take care of this infrastructure, servers, hardware, security, management, maintenance of the server. They'll take care of it, and you don't need to build any application also. So the thing is, you will simply write the logic, just like a single Java program. You take a single Java program, and you want to write all the logic in single Java program as a function, and you want to deploy it there. So you're focusing on the logic, how you can write the whole logic in a single Java function, and you want to deploy that function in a cloud serverless function, as a cloud serverless function. And when you deploy it, deployment, maintenance, load balancing, increasing this instances based on the demand, it will be taken care by the cloud team, other team. So this is a kind of feature. So if you get an idea, you simply write everything in a single function and deploy it there, and rest of the things will be taken care by other people who are managing the cloud, other things. Okay, you deploy your server functions, but in future they'll also come up with the you can write your business logic in one function and UI logic in another function, and you just deploy it there, you submit it to the cloud, and they'll take care of creating a web UI, and they'll try to take care of the backend code. So it will happen like that in future. You don't need to do anything. You just come up with if you come up with an idea, you simply write the things in single Java program as a function, and write your UI logic in single program, and rest of the things it will be taken care by the cloud. They'll provide different templates for UI, different templates, how you can visualize, how you want to visualize your UI application. So those kinds of technology trends will come in future, definitely. Okay, so serverless concept is also a very good concept, trending concept, because when the cloud and AI, these new tech stacks are emerging, we don't need to bother about the infrastructures, these things. We want to utilize, so when we get an idea, simply write the things using our code, and we'll deploy it there, and we'll integrate the cloud and AI into our technology. So with the features of the cloud, AI, and our idea, that will go into the online in minutes, or maybe in seconds also in future. You simply write your things in a single for a serverless function and deploy it there. Okay. So that is what I'm thinking. If you go little bit forward, maybe you can also, you'll be able to achieve this using simple English-like language. One day we'll have unified English-like language for programming as a programming also. Then we'll be able to achieve all these things using AI. It will simply build the UI. It will give us the interface, and the rest of the things will be handled by the AI internally. It will build the backend system. Okay, and if we just ask a prompt, and it will serve us the digital, to provide us the digital services. So I hope that technology is yet to come. It is happening now. Most of the people, they are building agents and MCP servers, right? One day that will come into the picture. Okay. So the thing is a scripting language. We'll discuss about the scripting language later. Okay. For now, this is all about it. Thank you.